Yeah, my name's Simon Brown. 5 things every developer should know about software architecture. So let's just jump straight in. Number 1, software architecture is not about big design upfront. This is probably the biggest myth I see here. You know, if we go back 20 plus years ago, people would say software architecture, and you'd get that reaction. Developers would go, no, we're not doing big design upfront. We're going to be agile, et cetera, et cetera. And there's lots of myths that have perpetuated after that point. So let's go back in time. Historically, there has been a tendency towards big design up front. Where has this come from? Stuff like the waterfall approach. For those of you who don't know this story, this is an image from a paper that was written in the 1970s, and it kind of typifies the waterfall style approach. If you keep reading, it says, please don't do this. It's a really, really silly idea. But nobody did that. They saw the picture and thought, oh, that looks nice. I can understand that. Let's do that. So even in that original paper back in the 70s by Winston Royce, he's kind of saying this is an approach, is not necessarily the best approach. And what's fascinating from my perspective is if you look and read through more of the paper, many of the ideas you'll see today in iterative and agile techniques are essentially talked about in that paper from the 70s. So of course, 2001 comes along, the Agile Manifesto was created. And one of those value statements says we value responding to change over following a plan. And on the face of it, this seems to turn everything we've ever known completely on its head. And that's why I have seen a tendency to not do lots of upfront design, because the Agile Manifesto says, hey, we perhaps shouldn't do that. The problem here, of course, is as an industry, we've generally gone from one extreme to the complete polar opposite. Now, I've been saying this for a decade now, and when I first started presenting this kind of picture, people would say, well, it's a straw man. Teams don't really drop all upfront design. Well, guess what? And I can see some people giggling. Guess what? Over the past decade or so, I have literally had teams come to me and say, look, we've dropped all upfront design, and we're now in a mess. Please come and help us. So yeah, we've gone from one extreme to the other. And there's a great quote I like to use here. Big design upfront is dumb. Agreed, for the most part. Doing no design upfront is even dumber. And that really epitomizes what I've seen over the past decade plus when I've been doing things like this around the world. So one of the questions people are really trying to answer here is this: how much upfront design should we do? If we're starting out with a blank sheet of paper, a blank whiteboard, we're doing a greenfield thing from scratch, or maybe we're adding some significant behavior or features to an existing code base. How much design should we do? And it's a really tricky question to answer because it kind of depends. What does it depend on? Well, sometimes you know what you're doing and sometimes you don't. So there's not a single approach that fits all different contexts here. If you're in a big enterprise and you need to build a system because of compliance or regulation that's coming in, that's a much more well-known set of inputs, set of requirements. Versus you've joined a startup, you're a product company, you want to push stuff out there, iterate, pivot, get feedback. That's a very different type of situation. So you need to do enough for the situation. You need to do enough for the context in which you sit. But this is kind of hard to quantify, isn't it? Like, how much is just enough? It's going to vary depending on who we are, what sort of things we're doing. We've seen a ton of these types of images floating around the industry over the past 10 or 15 years. Emergent architecture, evolutionary design. There's one that shows a bunch of pictures, and you start with a skateboard, and then you magically get a car. And that's a great cartoon to talk about product design. It's not a great cartoon to talk about the technical aspects of doing design. So this is one I prefer a lot more. It's by a blog post by Josh Kirievsky, titled Evolutionary Design Beginning with the Primitive Whole. And this is the same thing we've seen 1,000 times before. Start off with version 1, get your minimum viable product out there, add features, iterate, pivot, get feedback. So why am I showing you this today? Imagine we need to build this guitar, and each of these chunks takes a year. So we've got 4 years worth of work here. At the end of the 4 years worth of work, we can see exactly where we started and the changes between each of the steps. The problem becomes, on day 1, where are we going? So I don't think we talk enough about how do we put a decent starting point in place? How do we get a decent set of foundations that give us the ability to move fast and add features and iterate. So from my perspective, a lot of this is about putting a good starting point in place. What sort of things are we trying to decide? Well, not everything. That's what we used to do 20 plus years ago. So I guess to answer that question, we have to backtrack again and say, well, what is architecture all about? And there's lots of ways we can slice and dice different architecture definitions, but the one I like the most, because it's quite simple, it's to the point, is this one by Grady Booch. He says that architecture represents the significant decisions where significance is measured by cost of change. So there's a bunch of decisions you make that become hard or expensive to change as you progress. What sort of things am I talking about? Choices of technologies. If you choose to build a C# app, once you have 1,000 or 2,000 or 10,000 lines of C# code, C# becomes hard to remove and change from your code base. If you're building all of that code into a single monolithic deployment unit, that's hard to shift to a set of microservices in the future, of course. The libraries we use, the APIs we provide to our consumers, the data, how we're storing data, how we're reading data, querying data, how we're partitioning data. So from my perspective, that's the sort of stuff that becomes hard to change later. It's not stuff like white space versus tabs, right? Let's just put some tooling in place and fix it one way or the other. So let's focus on the important decisions become hard to change later. So yeah, just to reinforce this, we're not trying to decide everything. Martin Fowler said this a long time ago. If you dig through Martin Fowler's website, he has an essay about is design dead? And he says this: I think there's a role for a broad starting point architecture, such things as stating early on how to layer the application. So he's talking about code structure here, how we're going to structure the code inside our application, how you'll interact with the database if you need one. So again, anything around data, data structures. Once you have lots of data, it becomes hard to change and move. And what approach you use to handle the web server. So again, we're trying to figure out what decisions are going to be hard to change later, and maybe let's get those correct up front, or as correct as we can be given the context we have. So from my perspective, we're trying to put a starting point in place. We're not trying to decide everything. There is going to be some flex there, and we're going to have to do some evolutionary design and emergent architecture, but let's get a good starting point in place first. Why? Like, why do I want to do this? Imagine you're back in the office, you're having a design session, whether it's a greenfield thing or you're adding some features to an existing code base. You might be sketching some diagrams on a whiteboard, throwing ideas around, having some conversations about the approaches you might take. Off the back of those diagrams, you need to basically answer two questions. Number one, do the diagrams reflect the thing we think we're going to build and how we're going to build it? And question number two, are we confident it's actually going to do the job? Is it going to work? And so from my perspective as an architect, those are the two questions I want to answer before I start rushing into writing large chunks of a code base. To bring the whole agility thing back into this, and it depends and do just enough. Scott Ambler has a great essay on Agile architecture, and you can summarize that entire essay in this one single sentence. Base your architecture on your requirements. From my perspective, this is looking for the significant architectural drivers. There are a bunch of features that drive your architecture. There are a bunch of quality attributes that drive your architecture: performance, scaling, security, resilience, etc., etc. There are a bunch of constraints within your environment that drive your architectural choices. So you might have a bunch of enterprise architects saying, we only support Java in our production environment. That's going to drive you down certain solution paths. Or you might have a vendor relationship with Amazon Web Services. That's going to drive you down a bunch of solution paths. So there are some constraints in your environment typically. And then teams want to adopt a bunch of principles. So how do we structure our code base? Are we doing package by layer, package by feature, vertical slicing? Are we going to do microservices versus monoliths? How are we going to do logging and security and error handling and observability? Like, let's get those things decided first before we write lots and lots of code. So base your architecture on requirements, travel light. This is really reinforcing the agility thing, be lightweight, and prove your architecture with concrete experiments. A concrete experiment is literally nothing more than all of that stuff. Proof of concepts, prototypes, spikes. We have tons of names for essentially the same thing. Write some code, prove if something works or not. The interesting part from my perspective here is, how do you figure out which concrete experiments to create? I mean, you can prototype the entire code base if you want to, but that's probably a waste of time. So how do you pick the parts of the code base that are worth prototyping? RUP has the answer. So whenever people ask me about how do we manage risk on our Agile projects, my answer is go and read the Rational Unified Process book from 25 years ago. Now, please don't do that because it's very, very thick and very boring. But the Rational Unified Process is a risk-driven approach to delivering software. And what it does is it kind of pushes the risky stuff to the early parts of the project lifecycle. And that's essentially the same thing we can do today. We can identify and mitigate our highest priority risks. There's a bunch of stuff underneath the covers here about how do we identify risks, how do we prioritize risks, how do we quantify risks. Let's assume we can do a bunch of that stuff. In terms of identifying risks, I have a technique you'll find in my book. It's called risk storming, which is a nice, simple, collaborative approach to identifying risks. So these could be technology risks, risks with frameworks, APIs, security risks, et cetera, staffing risks, whatever that might be. And I see a lot of organizations doing threat modeling these days, especially organizations who are pushing stuff into, say, public cloud environments. They're more keen on making sure that their architectures are secure by nature. So I weave all of these different things into my definition of upfront design and therefore architecture. So to come back to that tricky question, how much upfront design should we do? The problem with asking this question is it gets you dumb answers. So if you ask this question, somebody will respond, oh, you should do 1 week. And that's it, and they won't give you any more answers. So the assumption I like to make here is quite simple. Let's assume we are going to do some degree of upfront design. So let's assume that's a given. And a more interesting question then becomes, how do you know when to stop? So from my perspective, upfront design is an iterative and incremental process. You might require multiple passes. History shows that's generally true. But how do you know when to stop doing iterations and just start kind of getting into the major code writing phase? If you have a good handle on the things that are driving your architectural decisions, you're in a good spot. So have you identified the significant requirements, quality attributes, constraints, and principles? Do you understand the context and scope of what you're building? I'll come on to say, are you able to draw a system context diagram saying these things are inside our system boundary and this is the world around it? Do you understand the significant decisions you're making in terms of technology choices and also things around structure and modularity? Do you have a way to share this information with other people inside your team and outside of your team? So can you correctly and adequately craft up a set of diagrams or documentation to share these ideas with other people to create a technical vision? Are you confident that your design satisfies the drivers? Do you think it's secure enough? Do you think it's fast enough? Have you done concrete experiments where necessary? And are you comfortable with the risk profile moving forward? Sure, you don't need to answer all of the risky questions, but have you confidently and confidently answered the highest risky parts here? If the answer is yes, you're done, you can move on. How do we get to this spot? Well, that's our toolbox. There's a ton of tools out there in the industry that we should have as developers and architects in our toolboxes. There are lots of newer techniques here like events modeling and event sourcing and impact mapping and all the Wardley mapping stuff as well. And then you've got lots of older techniques, shock horror, some of these are actually quite useful, object-oriented analysis and design, CRC cards when not done at the classes level, maybe pop it a couple of levels up in terms of abstraction. You've got some formal and informal architecture review techniques like ATEM and TARA, architecture dry runs, my risk storming. There's a whole bunch of stuff that I think we should have in our toolbox there. So just to reiterate here, we're not trying to put a perfect end state in place, something we always aim for rigidly and we must never move from. We're trying to do enough upfront design to create a good starting point and set an initial direction. I'm happy for design directions to change, but let's make sure that any design directions change for valid and justified reasons. Not because somebody went to a conference and say, hey, let's do serverless because it looks cool. Right, that's not the best way to approach software development. So my general approach is this. We do some degree of upfront design, put a starting point in place, but we need to admit we don't know everything and we never will do. So we are going to have to make some changes and evolve as we progress through the life cycle. So that's point number one. Don't worry, they get shorter from here on out. Number two, every software development team needs technical leadership. So one of the things I first started seeing a lot of 15, 20 years ago is people saying this: software development teams don't need architects. This was a backlash to what was typically happening at the time, which was those big ivory tower architects kind of telling development teams what to do. Like, here's a document, just do this thing. And teams wanted to work differently. They didn't want it to be restricted by what ivory tower architects would be telling them. So that's why I saw a lot of people kind of saying this. Do I agree with it? Yes and no. I don't agree with why it was said, but I do agree with those words as written in that order. What I mean by this is teams don't need a person who has an architect badge. That's irrelevant. Teams do, however, need technical leadership. From my perspective, this is the much important point lurking beneath the covers here. All teams need some degree of technical leadership. Why? Because if you don't have good technical leadership, you get a complete mess. Big balls of mud, spaghetti code systems, inconsistent approaches solving the same problems, multiple people using different data access frameworks in the same team, seen this a bunch of times, et cetera, et cetera, et cetera. So yeah, every team needs some degree of technical leadership. And this applies to all teams. If I'm a one-person team, I need some degree of technical leadership. If I'm a 1,000-person team, we need more of the same thing. So from my perspective, all teams need leadership. It's just the scale of leadership that essentially changes. Point number 3, the software architecture role, I'm going to come on to that in a second, is about coding, coaching, and collaboration. This is not just doing design and telling people what to do, as Dylan alluded to in the intro. A quick story. So I used to work in London for a bunch of small consulting companies, and I was generally part of the team who would interview other developers and architects who come and work with us. So I got to do a lot of interviews, which was quite fun. And I did this one interview one day, and this guy came through our door, came to our office, says, "Hi, nice to meet you. Take a seat. Tell me about your current role." And he started introducing himself. He said, "Hi, I'm a solution architect. I work for one of the big top 4 consulting companies. I'll let you guess which one you think it is." And I said, "Okay, nice to meet you. Describe your role. What do you do? What's your day-to-day job?" And he said this: "So I'm a solution architect. I go to our customers. I have conversations with them, have workshops with them. I figure out what they want us to build. I then take all this information, go back to my office, go sit in my office, do some analysis, do some design, and draft up a software architecture document. And I give it to a team of our developers, and they build it." And he stopped talking and sat back. I'm like, "Wait, what? What do you do next? Are you part of the team building the thing?" He said, "No, I'm a solution architect. I go to another customer, and I repeat the process." I'm like, "I have questions. What happens if the developers don't understand something in this document that you've given them?" And they're like, "Well, I'm busy, but they can email me, and I'll get back to them at some point." Right? Do you have any involvement in the thing that's being built whatsoever? Do you oversee it or get involved in the coding activities? No, that's not my job. It's their problem. Right? What happens if they build something different to what you've written in a document? What happens if they can't get your design to work? And he basically said, "Not my problem." He essentially said it's an implementation detail. If they can't implement what's in that document, it's their problem, not mine. What an ass. He was basically delegating all responsibility to the poor, unsuspecting team of developers. This is like the seagull approach to consulting. You get some external consultants in, they swoop in, they crap all over your team, and then they fly off and you have to clean the mess up. This is exactly the same thing. So it's ass. It's architecture as a service. This is like a one-way stream of some degree of architecture decisions. And of course, the thing that's missing here is the feedback loop. There's no feedback loop. The easiest way to fix this is to get the architect be a part of the team, then you get some continuity of ideas and you get the feedback loop. And if that's really not possible, you grab one or more of the actual developers and pull them to the front of the process. So again, you're creating that feedback loop. So when I spoke about technical leadership in the last point, this is a continuous approach to technical leadership. This is not just getting an architect in for 4 weeks, having them do architecture stuff and then leave. This is a continuous approach to technical leadership. Now, one of the tricky things around this topic is, well, how do we approach technical leadership? And is there one-size-fits-all approach to leadership? And the answer is no. Different types of teams need different leadership styles. And this is one of the things I've kind of learned the hard way during my career as a tech lead, developer, software architect. Every team is different. And they all need leading in different ways. Some teams you can just kind of let them get on and they'll do the right thing. And some teams need to be babysat. You need to tell them all the little steps because they don't know how to do things themselves. And that's essentially what Roy Oshiro says in his book, Elastic Leadership. So I'd highly recommend this book in terms of different approaches to leadership. This book's not specific to technical leadership. This is really talking about general team leadership, but the concepts are equally applicable. And the concept here is, imagine you have a spectrum, a scale. On this end, you have your very chaotic teams. These teams do not work well together. They're always running around with their heads on fire. It's just a mess. Everything's a mess. On the other end of the spectrum, you have your team of rockstar, ninja, 10Xs, or insert other silly names to talk about good people. These people down here need to be babysat. You need to figure out what their problems are, present them a solution, and say, do this set of things to solve this problem. So you need to give them all of the steps. It's a very command and control style of leadership. If you apply that same approach to your rockstar ninjas, that's just going to backfire. They're going to go, no, please go away. We know what we're doing. So again, different leadership styles for different teams. Even with these folks down here who are running around, their heads on fire all the time, you can't always tell them what to do because they'll never learn. So you do need to let them fail occasionally, maybe in the small, so that they can evolve their knowledge and experience and become more mature and hopefully get to this end of the spectrum at some point. In terms of how do you do this in a real-world perspective, pair architecting is something I've always done. We talk a lot about pair programming, but something I've always done is pair architecting, where it's been me and a colleague at the whiteboard putting together a solution. This doesn't need to be two peers with the same level of experience. It could be you and a completely junior developer. It doesn't really matter. Two heads better than one, continuity of ideas, challenge each other, reduce the bust factor. There's lots of good things here. I've just read and reviewed this book by Andrew Harmon Law, Facilitating Software Architecture, and something that's present in the entirety of this book is what he calls the architecture advice process. And this is really interesting. This book is either just coming out now or it's out in like a couple of months or so. I think you can get the preview on Safari. The thing that's interesting here is architectural decisions tend to be quite a centralized thing with a small number of people in a team making those decisions. A team could be a development team or an entire organization, of course. The architectural advice process flips this whole thing on its head. It basically says, here is a set of techniques that you can use if you want to decentralize the architecture decision-making process. There are pros and cons of doing this, but I'd highly recommend having a look in this book and reading through it and seeing if it might fit what you're doing. The thing that underlies all of this stuff, of course, is having a good set of soft skills. Interpersonal skills, human skills, whatever you want to call them. This is the stuff we don't teach well in the industry as a whole, as a kind of typical general thing. So a lot of the software architecture role, and this can be one or many people, is about leadership. This is a leadership role. We're trying to get people going in the same direction. If you can't communicate and present your ideas, you're kind of stuck. This is about influencing. Changing direction is about influencing. And you've got overt influencing techniques like persuasion skills and maybe neuro-linguistic programming or Jedi mind tricks. No, this isn't the architecture we're looking for. Move along. Right? There's a whole bunch of ways you can influence people. It's about negotiation. Maybe you are crafting a software system made up of a bunch of microservices. How do you negotiate what the boundaries of the services are? Are they all sitting in your team or outside your team? A lot of this is about collaboration. It's all about working with people. Right? Building software is a people thing after all, of course. It's about coaching, mentoring. One of the problems I see many organizations have is that they have a bunch of really smart people who have lots of architecture and design skills and knowledge, and then they rip them off sideways into management roles so they can get more money. And then all of the juniors left have kind of lost all their technical mentors. And I think that's a shame. So I think coaching and mentoring people about architecture on the job is a great way to kind of fill that skills gap. Rather than saying, please go and do this thing, explain why. Explain the process you got to making that architectural decision. This is why, by the way, things like architecture decision records are super useful because we're capturing the decisions, we're capturing the consequences, we're capturing the context. And that's really useful training material for other people in the future. It's about motivating people, it's about facilitating discussions. You're never going to get consensus, so you need to resolve conflicts. And of course, there's also some tricky political stuff hiding behind the scenes here. So I'm not saying that you should get good at doing politics, but understanding politics of the environment in which you work can sometimes help you understand why people are making weird decisions. As I said, we don't teach this stuff, so I'm going to point you to a couple more books. The first one's called Talking with Tech Leads by Patrick Qua. This is a really interesting book because it's basically a bunch of stories and interviews with people who are in tech lead roles. Some are new, some are more experienced. And many of the stories go like this. The tech stuff is easy, but nobody teaches you how to deal with people. And it's all the stuff you think it's going to be. You've got a set of coding conventions, and there's one person on the team who will never follow them. How do you get them to fall into line? Or there's one person, and they never commit their code to main before they go home for the weekend, right? How do you get these people following what everybody else is doing? The other book here is called The Software Architect Elevator by Gregor Hope. This is a fabulous book that talks about software architecture. It doesn't really talk about architecture from the technical perspective. It really talks about architecture from the soft skills perspective. And the general kind of metaphor is this. Imagine you have a tall tower building. This is the only part I don't like. All of us, techies, are in the ground floor and the basement. If anyone has seen the IT Crowd, it's a British kind of sitcom thing. It's the same thing. All the techies are down there. As you go up to the top floors of the building, that's where the CEOs live. And as you go further up, you've got middle management. If we have a messy, horrible, smelly code base, and we go to CEO and say, hey, we have a bunch of technical debt, and it's slowing us down, they're going to be like, I don't care. Go fix it. So we need to start talking about things in language that the other people will understand. So don't talk about messy code and code smells and technical debt. Talk about risk of reputational loss and security issues and monetary loss and all of that sort of stuff. And that's really what this book is about. It's about talking to people in a way that they'll understand. The coding part is always something we struggle with. Should software architects write code or should they not write code? From my perspective, and something I've always done during my career, is I've been on the team writing the production code with the rest of the development team. So my preference here is, yeah, people who are on-team architects, you might want to call these people tech leads. Naming aside, the people inside the engineering teams who are doing architectural work, they should be part of the production code generating people. It's a feedback loop. We get to feel our own pain. The problem here, of course, is the bigger the team, the more architectural work you'll have to do. More meetings, more conversations, more soft skills stuff. So maybe it's about doing concrete experiments and prototypes and putting some foundations in place, or doing code reviews or experimentation. So all of that aside, I think there are some ways you can still get involved in the real world activity of building systems. And that's why, and this should come as no surprise, I guess, most good software architects happen to be good software developers as well. You don't need to be the best coder on a team, but generally most good software architects have a good degree of software engineering background and experience. Why is this important? Because when you're making technology decisions, when you're making architectural decisions, you need to understand the underlying technologies so that you can assess trade-offs. I've seen a whole bunch of architects who don't know anything about coding drawing up really stupid architecture diagrams. Oh, we're going to have a cloud and then an arrow and a database, like just make that work. There's a little bit more to it than that, and that's where kind of our jobs come into play, of course. So it's all about, again, answering those two questions. Do the diagrams reflect what we're going to build, and is it going to work? If you can't answer those two questions, you shouldn't be designing software. End of story. So the software architecture role is very multifaceted. So the reason I call this the software architecture role is because it's a bunch of things that need to be done on a team. It can be done by one or many people. That's an orthogonal, different side story. But the role itself is very multifaceted. It does require a good bunch of deep technical skills a breadth of technology knowledge around design patterns and architectural patterns and building secure systems and fast systems and scalable systems, but also having that underlying soft skill base to fall back on. So it's a hard role, and it's a role that you generally grow into. You can't just get promoted and become an architect. Point number 4, my favorite, of course, don't need to use UML. This is one of the things that scares a lot of people away, unfortunately. They're, oh, I don't want to get into architecture because UML. No, please, let's decouple these things. In terms of UML usage these days, it's really low. If I poll an audience, in fact, let's do it. Who's using UML here? Like 6 or something. Okay, that's much less than normal. Normally it's about 10%, and then when you ask, it's like, oh, we only use class diagrams and sequence diagrams. So even out of the 20 or whatever UML diagram types, people only use 2 of them anyway. But yeah, UML usage is really, really low these days. Why? I've heard all of these things said to my face. Are these valid reasons? Probably not. A lot of them are just excuses. I was running a bunch of workshops for a very, very well-known company. I guarantee that you'll all know who they are. And they said to my face, if you use UML here, you'll be seen as old. I'm like, I'm the oldest person in the room. What are you on about? The tooling has historically been very poor. Anybody use rational rows? Ugly, and it just crashed all the time. People tell me UML is too detailed. It's not. UML is a language. The specification is 800-ish pages long, but you don't need to use the entirety of the language to draw some UML diagrams. Now, the problem becomes you're drawing a class diagram, you've got 2 boxes representing 2 classes, and you want to draw the arrow between them. Black diamond or white diamond? What does that mean? It's composition aggregation. What does that mean? So you do a search for composition versus aggregation on Google, and you get to some web page. It's like, right, imagine you have a car, and it has 4 wheels. If you destroy the car, do the wheels also get destroyed? Like, I don't know. And then you're down this rabbit hole of trying to figure out what all of the different relationships types are, and all you want to do is draw a damn line between 2 boxes on a diagram. So UML is not specifically forcing you to go to a level of detail, but there's something about the notation. People want to get it right, because there will be that one person on the team who says, no, that's the wrong arrow, like, after 3 days of figuring out composition versus aggregation. So a bunch of excuses. This guy had an interesting video about UML, and he says UML is a very elaborate waste of time. Right? And his answer was, drum roll, just use a whiteboard. Yay. Now, I know where he's coming from, and I know why he said this, and this is not bad advice on the whole. The problem is a whiteboard doesn't give you any guidance. Now, for those of you who know me, I've been running software architecture workshops. I've probably visited 40 countries, thousands and thousands of people, organizations all over the place. We get people to draw diagrams on whiteboards. I have gigabytes and gigabytes of whiteboard photos, and they all look the same. It's like, here's a bunch of boxes without arrows. Great. This is like, that's Frankfurt Airport. It's like a hub, and you can get to all the other places. This is just an utter mess. This box here says UI upside down for some reason. This one here, you could basically take a photo of and stick it in all your documentation, and it would work. So your system does a bunch of stuff, including business logic. Well, thanks. This one here doesn't tell you anything about technology choices. Why is that important? Well, I just said right at the start that architecture is about significant decisions, and turns out significant decisions include technology choices, so that's awkward. This one here looks like a bunch of C# microservices, but I think it's actually a bunch of C# things in a monolith, and this diagram is mixing different levels of abstraction, but our experience will point us to the wrong answer. There's this mess. Just like one of those adventure games, you get to choose different paths, and eventually you die and end up in the trap down here. All arrows lead you to the trap. This one here has a bunch of stormtroopers on. They're just faceless anonymous clones attacking this poor reporting service. And diagrams on whiteboard or paper just become an utter mess if you leave people to it. They'll just start explaining and adding more lines, and it just gets horrible. So a whiteboard is a fabulous tool, right? Joking aside, a whiteboard is a fabulous tool for doing collaborative design, especially if you're doing things like pair architecting. But it's the guidance around the diagrams that we need to focus on. And one of the questions people used to ask me before the pandemic is this a tooling issue? If I allow people to use a tool in my workshops, do I get better diagrams? And the answer is no. You know, if you do a search for software architecture diagram on Google, you get the same things, they just look nicer. They've got nice straight lines and readable fonts and rounded edges on the boxes and gradient shading and corporate color schemes, so they look visually more pleasing, but they're all just garbage as well. Why is diagrams important? Again, if you can't draw good diagrams, you can't answer these two questions. You're just stuck. You're having a bunch of conversations around a diagram, but the conversations are meaningless because the diagrams are meaningless. You can't evaluate or review the solution if you can't see the solution behind the visual mess. So from my perspective, teams need a ubiquitous language to describe software architecture to communicate effectively. What I find funny is over the past 10 plus years, we've all focused on domain-driven design and creating a ubiquitous language and bounded context. And you've seen this a lot in conferences. But as a bunch of techie people, software architects and developers, we don't have a ubiquitous language to describe our stuff from a technical point of view. So this is why I came up with the C4 model. The C4 model was basically me teaching teams how I used to draw diagrams in a kind of post-UML era. If you've not seen C4 before, it's basically a bunch of hierarchical abstractions and a bunch of hierarchical diagram types that allow you to describe software architecture at different levels of abstraction. And C4 is named after the diagram types. It's context, containers, components, and code. And it's the kind of underlying concept here is diagrams as maps. So I live in Jersey in the Channel Islands. If you open up Google Maps and you do a search for Jersey, you're going to get that picture. Google Maps will zoom straight in and give you Jersey as big as it possibly can. This is great if you want to know where the airport is and how to get from the airport to the main town where your hotel is. If you've never heard of Jersey, it's completely pointless. So how do you fix this problem? You pinch to zoom out, and now it's off the coast of France. And if you zoom out more, it's gone, because it's only 15 kilometers by 10. On the flip side, you can zoom in and keep going, and eventually you'll drop into Google Street View, which is a one-to-one mapping with the real world when those photographs were taken. And I want to do the same thing with software architecture diagrams. I want different levels of diagrams that allow me to tell different stories to different audiences. The high-level diagrams are useful for more people than the lower-level diagrams, and people kind of lose interest as we progress down the hierarchy of diagrams. So it's a really powerful way of describing and documenting software architecture, with most organizations only using the top two levels. That gives you the biggest bang for your buck, and the top two levels of diagrams don't age that rapidly. So if you want a nice summary of C4, that's essentially what it is. It's a hierarchical set of abstractions, it's a hierarchical set of diagram types, it's notation independent, and it's also therefore tooling independent. More information about C4 you can find at c4model.com. There's a video that's linked on there that gives you a nice overview from a conference talk a number of years ago. In terms of tooling, I have a bunch of tooling called Structurizer, and it's kind of a C4 models as code. So it's an as code approach to creating software architecture diagrams via a centralized model of elements. So you can find a bunch of videos called C4 models as code online. And all of the tooling that I've created is open source, it's all on GitHub, so that's all available for people as well. So point 5, to wrap up, a good software architecture enables agility. One of the things I've noticed over the past 10 or 20 years is that the Agilists have said architecture is bad, and the architecture people have said the Agile thing is bad, and they're kind of competing forces, and that's not the case. These two things are complementary. One of the issues we have in the industry is that the word Agile has lost all meaning. So if you ask a random selection of people, what do you think Agile means? Most of them will say this: Agile is about moving fast and embracing change and releasing software quickly and getting feedback and all of that good stuff. And it is, right? Don't get me wrong. But this is missing the point. This is really just iterative and incremental development done well, done rapidly. It's the very mechanical, process-centric view of agility. And that's fine, it gets you a long way, but the real underlying point around agility is that mindset of continuous improvement. It's not always doing the same things every day and just ticking the boxes because that's what we've been told to do. It's about looking for ways we can improve what we're doing. It's about looking for things that have gone well and celebrating them and trying to fix any problems as they crop up. And don't forget, we're applying this to the way that we work as teams and team units, and we're also applying it to our code bases. We're applying it to our architectures. We have a system, it's in use. We need to add a new feature. We need to essentially inspect and adapt. We inspect the current code base, and we figure out how to add the feature, and then we adapt it to add the feature. A good architecture enables agility. A good architecture allows you to move fast. This is very subjective. What do I mean by a good architecture? For me, a good architecture is one that has a good degree of modularity. It's one that has a good structure. And this makes sense from a kind of gut feel perspective. If you've ever worked on those horrible big ball of mud style code bases, when you change some code up here, often some code down here breaks, and you don't know why because it shouldn't be connected, but it is, and it slows you down. It's very fragile, very brittle. If you have a code base that has a high degree of modularity, a high degree of structure, it allows you to move faster. You can make changes inside those small modular parts, and you don't get that horrible blast effect or ripple effect that breaks other parts of your code base. It's easy to kind of move fast if you've got well-contained parts to work in. You don't get that for free. There's another great book on software architecture, I highly recommend, by George Fairbanks, Just Enough Software Architecture. And he says this: a good architecture rarely happens through architecture in different design. This is just jumping on a solution because that's the way we've always done things, or hype, trend, fashion. And of course, we see a lot of this these days with things like microservices and serverless. People go to conferences, Netflix is speaking, oh, that looks marvelous, we'll do that too. No, you're 3 people. You don't need a completely distributed architecture for your little business app. So we need to make sure that the decisions we're making are useful in the context in which we're making them. But we don't do that. And I've seen a ton of people over the past few years who have these 10, 15, 20-year-old legacy Java monolithic applications, and they're hard to change, they're hard to add features to now. And they realize that maybe microservices is the answer. So they go to all the conferences, they attend training courses about how to build a microservices architecture. They're like, right, we're going to transform our monolith into a set of distributed microservices. Hooray. But what happens is they take their monolithic thing, they find the seams, they apply all the patterns, they find the seams, and they stick synchronous network calls between things in their mess. And then they get a distributed version of the mess they had before. And now it's even slower, it's even more brittle, it's even more fragile, and it doesn't scale whatsoever because you've got all of these synchronous JSON calls across HTTP network connectivity. They've missed eventual consistency and messaging and all of the other good stuff. So that's why I talk a lot about modular monoliths as being a potentially better starting point for most teams. This is hard to do. You need to apply tooling and develop a discipline, but maybe it's easier to refactor things in a single code base and then promote them to be distributed services in the future. Sure, I get there are lots of benefits of microservices architecture, Conway's law probably being the biggest of these, but a lot of people are not ready for that degree of sophistication. And of course, we could also have a hybrid. You know, we always like talking about extremes. It's either this thing over here or this thing over here, and there's nothing in between, except there is. There's nothing preventing you building the majority of your features in a single monolithic unit, and then having a bunch of distributed services around the edge. And maybe those distributed services are representing the more volatile parts of your code base, the more volatile parts of your business process, or the parts where Conway's law makes sense, and it makes sense to spin those things off into separate teams with separate ownership and separate release cycles. How do you figure out what sort of architecture to build? Use agility as another driver. Figure out how much agility you need and where that agility sits across your architecture, and use that as a way to come up with an initial starting point. Now, AI is very hyped, and I'm not going to talk about AI. This is the closest I'm going to get. I see you have a poorly structured monolith. Would you like me to convert it into a poorly structured set of microservices? No. So just tread carefully with all of the hype and trend and fashion. And that is 5 things every developer should know about software architecture. Thank you very much.